You should see now presentation number 3 is with the title Introduction to a Conceptual Site Model. The content of this presentation is, first item is, what is an initial conceptual model? And take care, I leave away the site here. What is an initial conceptual model? And then what is a complete conceptual model? Then I will go into the definition of a conceptual site model, also abbreviated as CSM. And just a remark, in the summary of the guidance, so the first document on the website, we have a list of all the abbreviations used in the models. So if you do not understand certain abbreviation, you consult the summary, and there all these abbreviations are there. Okay, then the next item I want to discuss is the conceptual site model input. So what is needed to make a conceptual site model, and then I will finish this presentation with some examples of a conceptual site model. So what is an initial conceptual model? So can anyone tell me what this initial conceptual model try to present? I mean, it's simple. It's the initial conceptual site model of a cat. Easy. So you have some information here, but because this is very clear, you already know that this picture is a cat. But a cat can also be this one. This is also a complete conceptual site model, a conceptual model of a cat. So it's clear. So the cat and read instead of cat site can be different. So this conceptual model of the site will differ as this conceptual site model of a cat differs. Now here is another initial conceptual model, and who can tell me what this is based on your experience? And here it comes. Based on your experience with this minimum information, you can already tell a lot of what I want to picture here, what the conceptual model is. Any response from the audience?
Is that a car?
Yes. And what type of car is it?
Probably a race car.
Yes, exactly. Now it's simple, but with this small information, you already can tell a lot. You can even tell something about the characteristic of the driver. So meaning that this is a clear example of knowledge you have, and with that knowledge, you can already tell a lot. So that is important for the design of a conceptual site model. But as an example of a conceptual site model, how many pieces of this you need to completely understand? Here you have no reference, nothing is clear, and you have no clue what it is. This is it. And this is probably your soil. So a definition of a conceptual site model is a model of a site that describes the distribution, release mechanism of sources, exposure pathway, and migration routes and potential receptors of the contaminants of concern. It's visually oriented, comprehensible representation of what is already known about the site. So be aware what is already known about the site. That's the definition. The goal or aims of a conceptual site model are to organize all available historical and current information and facilitates the identification of information gaps. And information gaps are the uncertainties. And it pictures and describes the source of contamination, the receptors, and the source receptor pathway. So a conceptual site model is only complete when you have pictures and describe. So also the report is part of your conceptual site model. When you describe the receptors, the source receptor pathway, and the source. And that's why it's important that you know the processes in the soil, because the processes deal with the source receptor pathways. And the conceptual site model is a tool to support site information sharing and discussion. So when you have a good conceptual site model, you can easily explain what is going on this site. What is the danger? What are the risks? A conceptual site model is also a tool to support decision-making processes by reducing management uncertainties. Here again, the uncertainties, you formulate the uncertainties, the gaps, but you can also take actions to reduce and to manage the uncertainties. Managing uncertainty can mean you deal with it or you take actions to clarify. And the conceptual site model is also the basis for optimization site-related decisions. With a clear picture of what is going on, you can take good site-relation decisions. When you don't know what's going on site, it's tricky to take decisions in relation to the site. The conceptual site model is visually oriented. So meaning make use of tables, photographs, pictures, diagrams. because people think in pictures. One picture tells more than 1,000 words. But a conceptual site model is not only a set of pictures from the on-site contamination, it is also site data organized and presented in such a way that it is easy to understand the on-site contamination. So it's not only pictures, so with the pictures, tables of analytical results clearly. And as example, I see often reports, and then you have your appendice, and then it's a lot of information in the appendice in analytical reports. That's not handy. Make sure that you have this in a nicely presented table, easy to get the idea. So tables, pictures, diagrams. But a conceptual site model is not reality. It's an approximation. It is what you think. It is how you did the interpretation. And therefore, if you construct a conceptual site model, you should consult your colleagues who are having, let's say, different subjects of interest. Consult your soil scientist, consult your chemist, consult your geohydrologist to have your approximation the best way proper. But it still remains an approximation. The conceptual site model is essential in all phases of the contaminated site management to design a good site investigation strategy, to design and execute appropriate risk mitigation measures, and to sustainably manage contaminated sites. So in all phases, and these are 5 phases, phase number 1, the preliminary site investigation, phase number 2, the detailed site investigation, phase number 3, the remediation assessment, 4, the remediation itself, and 5, the monitoring and aftercare. So in all phases, the conceptual site model is an essential tool, and in all phases, it should be updated, because in every phase, you gain more information of the site. And in phase number 4 and 5, the situation is changed due to remediation. So if the situation is changed on site, you have to adapt your conceptual site model. What is needed to construct a conceptual site model? What are the pieces of the puzzle? Site history, site surrounding geology and hydrology, site, the soil type, structure and heterogeneity, contaminant type and properties, contaminant situation, load, location, state and extent, contaminant fate and transport and migration, geochemistry and weather conditions, and natural attenuation potential. And this, of course, is a summary of what I explained earlier, fate and transport processes in the soil. And the conceptual site model should always reveal the potential or identified sources of contamination, the potential or identified exposure pathway, the contaminant migration route, source pathway, and the potential or identified receptors, exposure and uptake. So the conceptual site model team, to construct the conceptual site model, you need a team, and this is you with your expertise, but besides that, you have site investigation specialist, soil scientist, hydrologist, specialist in contaminant behavior, the toxicologist, remediation engineer, and project manager, and many more. So many different disciplines. It's teamwork. So and next to that, allow to work with a flexible work plan, because you don't know what the on-site situation is. So you need a flexible work plan in time and money. This is an example of a conceptual site model. And before I go into this, I would like to have a 5-minute break because my battery of my earphone is low. So I will change to other device. So please give me a few minutes to change. Okay. Sorry for this this intermezzo, but I would like to give you some examples of a conceptual site model. This is an example of initial conceptual site model for pesticide stockpiles in Sao Tome. Sao Tome is a small island opposite Nigeria, and it's on the equator. Based on a site visit, share. But meanwhile, I can give you some information how to construct an initial conceptual site model. Meanwhile, they can give me the authority to present. But initial conceptual site model is made with the minimum of final investment. It's based on expert judgment. You go to a site, you take a photo report, you interview people, and you try to get as much as possible information from archives, historical information, company archives, and so on. And with this information, you construct your understanding. And this phase is not, let's say, based on sampling and analytical results. It's just a phase where you make an inventory of what you have. And with that information and your expert knowledge, construct your initial conceptual site model.
I am asking them, I am asking,
Okay.
even if I don't say, I am asking. In any way, we have two questions also, Mr. Fogg.
Okay.
If you
Okay.
want, we have on the chat. One is from Abdallah Haim Uwais, sorry that I don't pronounce correctly, that he mentions how to know that our conceptual model has been constructed properly and it can be used satisfactorily, especially in the case of the shortage of information. So when we don't have enough information, how we know that the constructed conceptual model is working on?
The conceptual site model starts with first the collection of the information I just told, all the site information you have. And with that, you construct your understanding. But of course, you have gaps in your understanding, and these gaps are your uncertainties. And that has to be, let's say, formulated. Your gaps in your understanding have to be formulated. And the gaps direct you to the next phase, which is the detailed site investigation. So based on things you do not know, you make a survey and analysis plan. And with these surveys and analysis plan, you carry out your detailed site investigation. And with the information, you build your conceptual site model. So building a conceptual site model is a circle process. Every time you improve, and that means that you need to be aware of what you do not know. So a conceptual site model is actually a constant involvement of new data and new information and new understanding to construct your conceptual site model.
The second question, while we wait, it's related to this, because the answer is very well explained, but the other question is, if historical information about the area is not available, including the cause of pollution, how can this gap be filled? So I suppose it's related to...
Yeah. So you go to a site and there is no information at all. And that is in many cases the case. I mean, there are sites which have no information, no archives, but there is a contamination discovered. And then you should go to the site and properly look for sources of contamination, potential source receptor pathways, and potential receptors. And you do that by interviewing people who live near to the site, ask what they experienced, and look at all the site components which may or may not have contaminated the site. And look also at all the site features, pavements, raised land, or pits where you may have dumped waste. So you just start designing your understanding of the site. I mean, that's the whole point. If you come to the site at the first phase, you do not know anything, but then you build up your knowledge, and you build up your knowledge during every cycle of investigation. And the first step is your preliminary site investigation, where you build your initial conceptual site model. The example of the cat is easy. I mean, when you come to a site and there's a tank leaking, then you know, okay, this is TPH or oil or gasoline is leaking. And when you see that's a sandy soil, then you know that it migrates very quickly. So that's the cat. But the last picture where you have these ducks is a site where you do not have any information. And then your gap analysis is huge. And so your investigation efforts are huge. So each site should have a site-specific approach based on your understanding, also your own experience, and the available information. So when you're very experienced, you come earlier to the conclusion on the site situation than when you have no experience. So therefore, the team building a conceptual site model should involve all expertise available: hydrologists, civil engineering, construction engineering. For instance, if you have a site with a building and the building is contaminated, you need to know how the site was constructed. And that gives you also the information on potential pathways. Okay, I have to start again. Okay, this was my last slide. This is the initial conceptual site model. So with a minimum of information, consulting local people, going to the site, make a site photo report, I designed or made this initial conceptual site model. No archives were there, only I visit the site. So what I saw here is this picture on the left-hand side. This is inside, drums with pesticides. Then here, a sink covered with waste. Then inside the store, all waste and pesticides, and here bags. So this is the map. So if you go to a site, you try to construct your own map when you do not have it. Then you see these lines: A accent, B B accent. These are the cross sections to be made to get the idea of how the contaminant may migrate into the soil. But besides that, look at this picture. There's always on the map is an arrow to the north and indication of the scale. So the scale, this is a very large scale. It's 7 meters and 9 meters. So if you produce a map, it should have a scale and a north arrow. And of course, a legend explaining what is on the map. This is the cross section. And here I have given a 1 for the source of contamination, 2 are the potential exposure pathways, the migrating routes, and 3 are the potential receptors. And you see potential because I did not confirm that by sampling and analysis. So I think that this is the potential pathway, and I think that this is the potential receptor. So here again, A accent, my store, my waste, the windows, and the question marks are the gaps. I do not know if the contaminants inside has infiltrated under. The outside, I had drums. I do not know if drums are leaking and have infiltrated into the soil. So here these question marks are already directing to what I should survey in the next phase. And groundwater was also was expected to be very deep. So I because of my understanding of the geological situation, I knew that groundwater was not an issue here. But the question marks are your uncertainties, your gaps in your conceptual site model. And here, this is the photo report. So you make photos of potential pathways. For instance, these are the windows. So birds may fly in, come in contact with the contaminants, and then the receptors are the birds, the ecosystem. Here, outside spots of burning that may have impacted the soil. And here, trees close to the window, and here the drums outside. So this already gives you an idea of the situation on site, and the question marks are your uncertainties, the gaps in your understanding. But this is another one. This is initial conceptual site model of a production site of the Lindane in North Macedonia. And this is far more complicated. The red lines is my survey area. This is the understanding, and the main source of contamination were here, stock of drums, and here pits with waste from the production of Lindane. And this was an electrolysis plant where we suspect mercury contamination. So this is what was expected. Migration of contaminants due to infiltration of rainwater into the groundwater, because here we knew that the groundwater was around 2 to 3 meters. We expected that. That has to be surveyed, but we say no, we may be faced with contaminants in the groundwater. And that is groundwater contaminated by 2 pits of industrial waste from the Lindane production and by leaching of the contaminants from the drum stock. Here again, 2 cross sections, A accent and B accent. And this is what I expect to be the situation. Based on information, I knew that there was an aquitar, and aquitar means that there is somewhere in the profile a soil horizon which is impermeable for water. And I knew also from my experience that if you have wastes from Lindane production, they may contain chlorinated hydrocarbons which are heavier than water, and they form a DNAPL, a dense non-aqueous phase liquid, and that is heavier than water and sinks through the soil down to the aquitar. So this is the situation. And here, the drum, we expect contaminated soil, and we expect the groundwater to be contaminated in a plume. Now, here again, the same figures, the 1 for the sources, and the 2 for the pathways, and the 3 for the receptor. So this is, the receptor is here the birds, the ecosystem, illustrating the ecosystem, but it's at the same way a pathway. People working in this plant, it was a shoe factory was besides, they are of course also the receptors and the factors, and we didn't know if the building was contaminated or not. So in this picture, I have tried to give my understanding of the on-site situation in relation to the contaminants on-site. So this is the transact in directions B1 and B, more or less the same way, but this is in direction of the flow of the groundwater. And this is what I expect. Here again, the DNAPL and then the plume. But this is also an initial conceptual site model. Here is an initial conceptual site model of a former gas factory making city gas in the old days. And by discussions, we took this, let's say, drawing by hand. We have an aquitar, we have sources, and we have a lot of gaps in our understanding. Is it true that here we have accumulation of contaminants? Is it true that this aquitar is interrupted? Is it true that this is that this factory is on poles and standing on this layer So this may also be factor in the migration of contaminants. So the question marks, you see them here, are my gaps in understanding. Is the sewer a source of contamination, or is the sewer a migration pathway of the contamination? Or both? How deep is the contamination migrated into the soil? Is it interrupted this layer? And so on and so on. These are my gaps of understanding. So a lot of gaps. And this should be clarified in the next detailed site investigation. And this is the same situation. And here, based on a lot of information, a lot of survey, here these are all the observations, 60, here the numbers of monitoring wells. And here, this is my complete understanding of the contamination situation. In this case, sorry, is a dry cleaning site. And here are the classifications of the concentrations in the groundwater. And here we use the yellow is below the accepted minimal level. This is between the trigger value. These are the concentrations above the remediation values. And this is 10 times. This is just above, and this is in between. So here the plume being designed based on a lot of information. And TEC is trichloroethylene, dry cleaning solvents. And this is done after many cycles of fieldwork campaigns. So the conceptual site model in all phases of the sustainable management of contaminated sites, it's dynamic and it is a continuous refinement. Phase 1, you have your initial conceptual site model. It is based on the information collected by desktop study and a site visit, and it's called the preliminary site investigation. Phase 2, you improve your initial conceptual site model to an improved conceptual site model. You do that with a detailed site investigation, and in this phase, you do site sampling and data interpretation. And this can involve several rounds of site sampling. Then the third phase, the detailed conceptual site model, site remediation, and this is used to design your cleanup, your site cleanup. Because also in this phase, you may go back, or you need to go back to the site to collect information to be able to design a cleanup. So new information of the site, you update your conceptual site, or you detailed your conceptual. Then we enter into phase 4, site remediation. You have carried out your cleanup, so the situation changed on site. You take away your contaminant. You have excavated so many tons of contaminated soil, so this should be changed in your conceptual site model. And as I earlier said, after remediation, you may have remaining risks, so remaining contaminants, and therefore you enter into your last phase, the phase of monitoring and aftercare. You sample and you take note of what is changed on site due to pump and treat, due to natural attenuation, and then the situation changed, so you update your conceptual site model. Conceptual site model is crucial in all phases of the sustainable management of contaminated sites. It's important. This is the most important tool to manage contaminated sites. Various information and disciplines involved. This is a summary of what I just tried to explain to you earlier. Visual-oriented tool to support decision-making process. Crucial in all phases of the sustainable management of contaminated sites. It's dynamic and continuous refinement and evolving. So it's important to mention every phase you collect information, you should update your conceptual site model to be able to share your understanding with all stakeholders involved in the management. And here is a diagram illustrating what I tried to explain. Your phase 1, it's called your preliminary site investigation. You do a site visit, desktop study, and reconnaissance survey. A reconnaissance survey is here, and I will explain it later, but it is a limited sampling when you want to have information which are crucial for the next phase in relation to health and safety and budgeting. I will give you later an example. The results of phase 1 is an initial conceptual site model, your first understanding of the site in relation to the contaminant on site. Your initial conceptual site model is subjected to a gap analysis, the question mark. You put your question marks. What do I need to know? What do I want to know? And then you have your first detailed site investigation. Investigation, sampling, installing boreholes, installing wells, taking samples of contaminated building material. Then you bring the samples to the lab, data interpretation. Again, gap analysis. Do I know everything? Have I enough information to proceed to the next phase? No, I do not have. So you continue again, gap analysis, laboratory analysis, interpretation, and so on. And this can be more than 3-4 cycles because you cannot see on site what the concentration, for instance, is in groundwater. You need to know by chemical analysis. And that can take a week, 2 weeks, 3 weeks, sometimes even 3 weeks, 4 weeks to a month to get the information. And then you come to the conclusion, no, it's still, we do not have mapped the contamination completely. So we have to go back. So be aware that if you start this process, you allow the investigator to have enough funds to carry out several campaigns of investigation. But when you're finished, you enter into the site remediation assessment, which is, let's say, the survey to the search for the correct remedial actions, which fits into your budget, which fits into your time, which fits into your objective. But here also you may collect, or you need to collect additional site information. Can be that you need to know the conductivity of groundwater in your profile because you think that pump and treat is a way forward. So you need to go to the field, do chemical analysis, do grain size distribution analysis or whatever. And these laboratory data should be interpreted, put into the conceptual cycle and improve in your conceptual cycle. And again here, do I know everything? The gap analysis to proceed to the next phase, which is the remediation itself. And in between, you have your design of your remedial campaign. But your remediation gives also new data, monitoring data I call this, and monitoring data are also brought to the lab, but can be also just physical observations. You interpret the data, you put them in your conceptual site model, you update it. You update your conceptual site model based on the new situation after your remediation. Then you enter into the last phase when you have remaining risk, you do the monitoring and aftercare, monitoring data, interpretation, and you update your conceptual cycle. I think this illustrates actually the full process which we deal today and tomorrow and the day after tomorrow. So this is important to understand the process slides because it's crucial for you to understand this.
Now you have one question. In your experience, are there any cases where cleaning up a contaminated site was impossible?
There are two questions, yes or no. A good example is a site near Amsterdam. It's 100 acres large and it's a former peat farm. So they were mining peat. And in the old days, they were bringing there on the way back household waste from the city of Amsterdam. And later on, when the industrialization starts, they also brought their chemical waste from I can mention the name, Phyllis Duvar. They were producing Agent Orange in Europe, Netherlands, to sell that to the Americans for Agent Orange. And they had a disaster. The factory exploded. And all the waste and rubble was brought to this peat farm without any protection. So years and years, this was an open dump with industrial waste. It's now already 10 or 15 years ago. The city of Amsterdam found it an unacceptable situation, and they asked two companies to remediate this site. And it was impossible. After many studies, it was found impossible to take away this waste. It would have been costing too much. So at the end of the day, it was decided to contain a risk, and containment is the last resources to manage contaminated site when you have not enough resources. And this was the case in our country. So the 100-hectare dump site with dioxins, with a lot of other chemicals in drums, pure products, was contained. And the containment was by constructing a cap on it. And the situation was quite interesting because the land around Amsterdam and Antwerp itself is in a peat formation, and peat is, as you may know, organic material underwater. And the peat turned out to be a good isolation for the migration of contaminants in the groundwater. So for many years, we did monitoring of the groundwater, and we found no contaminants outside this. Inside, the concentration was sky high. So the approach was as such that we installed a cap over this 100-hectare site. And because if you install an artificial cap, it should be replaced after the lifespan of such caps, which is around 100 years. To avoid that, we constructed ponds on this cap, and we allow peat to grow in these ponds, with the idea that the peat formation would take over the functionality of the artificial caps, of the artificial cap. So yes, we come across sites which cannot be remediated because of financial constraint and technical constraint, but then the only resort is containment. And another example is, for instance, when you have not enough resources to remediate a site, you change your site use. And the Americans have a nice say on this. If you put a fence around a contaminated site and you install signs and say, do not enter, do not dig, and you allow the vegetation to be restored completely on site, that's also a way of using mitigation measures to reduce the risks. And the American saying is the biggest bang for the buck, because if you install a fence and you do not allow people to come and you do not allow any use of the site, so site use restrictions, you already reduce a lot of risks. Is that clear? Omar, you have a question.
Yes, thank you, Fok. I have two questions actually. The first one, how many cats do you have? Because you presented so far like many cats in your presentation. The second question is, are there any softwares, for example, to design those pictures or diagrams, to identify the risks and the pathways, for example, the receptors, and design the advection and convections of the transport of that pups, for example, or that material. So is there any, now the AI is playing, important role, to design and save time and money, to design all these pathways, risk and potential.
Yeah. Now there is in my module we have a link to a website, to the Canadian Governmental Environmental Industry website, and they provide free of charge software package to make these kind of drawings. So there is software available, but mind you, that doesn't dismiss you from extensive survey to come finally with the conceptual side model like this. There is software. There is, for instance, also software to calculate this plume distance. So yes, there's a lot of software, and I will go into a bit more details in my next presentation on the tools to do that. But yes, software is there, but it needs data input. You cannot design any conceptual site model without going to the field, taking samples and bringing it to the lab and have your understanding. Does that answer the question?
Yeah. But you missed the first question.
Yeah, the first question, there are many cats. Numerous.
Okay.
I mean, there are no sites alike. Every site is different. So site-specific approach is important. But of course, if you have fuel station and you have analyzed or made site investigation on 10 fuel stations, you know more or less what you can expect. But still, the situation will be different. And that is, of course, the experience you have. I mean, when I'm going to a site where, for instance, to a large depot for fuel, I know where to look at, filling points, ventilation pipes, and so on and so on. So experience is also a very nice tool to have to do the site assessment. Are there more questions?
There is another one, Mr. Fogg. Well, two more. One maybe it's too specific, and this is there a way to remove ammonia from fish farms that combines plants and microbes at the same time? Is there, I need the best as reference? So I suppose to talk about ammonia from fish farms, it's far behind of the scope of this webinar, but maybe you have an answer for this.
No, it's a bit behind scope because there will be techniques to remove and filtering the water, but I will not go into details on the chemist, but pump and treat is a way. Nowadays, we have also absorptive mats being produced on the bottom of water to absorb the contaminant. So I'm not a chemist, but there are ways to get rid of this. And of course, pump and treat is the most easiest one. And pump and treat and then re-filter. Yeah. So sorry, no, I cannot get.
Yes, and the last one is how are CSMs reflect dynamic site conditions or long-term change? Example, seasonal groundwater fluctuations, contaminant degradations. What is the solution in this case? Do you have an answer for this? CSMs reflect dynamic site conditions or long-term changes?
Yeah, to be aware of long-term changes of dynamics into your sites, the degradation processes, and that you have to be aware of, for instance, of the degradation processes and make use of it in your remediation assessment. I'm still thinking about your disaster you had, I think 1 or 2 years ago, the large flood. In the guidelines, we do also say try to assess the vulnerability in relation to climate change disasters. So when you have, for instance, a dump site near the coastal area, and there is a change or there's a chance that this may be affected, you should take that into account while you search for solutions. And your question clearly illustrates that the conceptual site model should be dynamic and evolving and constantly be adapted to the change situation and to the changed understanding of the site. Because a change in the situation may also change your receptor pathway, for instance, and may enlarge the risk for ecological risk and for human health risks. Is that clear?
Yes, we understand. Yes. We say thank you to you.